Hello everybody, and welcome to part 8 of my little tree generation series. And I want to start off by fixing that mistake I made last time, and we are actually looking at it. You can see here where I make my new branch, I actually take my segments per branch and I decrease that with this decrease segments at branch. And this is obviously not gonna work because this is the fixed number, and what I really need to take is the local version of that. And if we now compile this and take a look at what we get 14 segments. If I increase this to 8, we get 47 segments. Okay, so I want to start to generate the tree itself, generate the SplineMeshes, and we did that last time, most of it. So I'm gonna start off by copying everything. It's not gonna copy completely, so I need to make some adjustments anyway. If we find the part where we render the tree, we need to make a function for that. Call this render tree, and let's paste all that stuff in here. Okay. Now the tree, it seemed to have picked up correctly. So this one, for each loop, we need to replace. And this is a break else system branch. It's going into this local width scale, which I don't have, so I need to make local width scale, which is going to be a float, which I'm going to replace here. And we also need to take this one out actually. So make a break. The parent width scale goes in here. And if you remember, we had a function we called in order to take the transform array and generate a point array. And we need to remake that one again. So I'm just going to do it here. It's kind of simple, I guess. So cast to vector array, which is going to take in a list of transforms, or an array, and then it's going to do a for each loop on them. And it's going to take out just the location, and we're going to add a local variable here to keep that. Just call it vectors. And then we're going to add this location in here inside the loop body. And once we're finished with that, we're just going to exit and return that array, local array here. Here, I'll call this vectors. Okay. And then we also need to call it. this one apparently didn't get set correctly. Let me just reset that. For some reason it does that sometimes. There we go. And then the for each part here is okay, and then I need to create a local variable for that. A new one. Like that. And replace that. Also here and here. Alrighty. And we also need to do something with this local scale. We have the width scale, which this is, we're going to have a local width here. So local width scale, which is a float. And that's the one we will set here. I'm not really sure there's an easier way to do what I'm doing right now, but anyway, it's not that big of a deal. But if there is an easier way, I wouldn't mind. Local width. And then we have the width scale, which is the segment width factor, I called it this time here. Okie dokie. Let's compile and see if we have more errors. We have one here because I forgot to hook that one up, and that should generate the tree. So we just need to make sure that we call it and the initialize tree. So we have render tree here. Let's call render tree like that. Save and compile, and we get nothing. So first of all, I want to make sure that we rotate this upwards like this, and then I need to start debugging this because I would actually have expected to generate something. So I have my list of points, and I return that list here, which seems to be okay. I do it for each, and I add my spline mesh, set the start and end, set the scale. The width is coming from over here, the local width scale. So that should be good. And we set the end, and we shouldn't update these two every time. And then we set this SM cylinder, which is okay, I guess. So everything should be generating. Just gonna set a breakpoint here just to make sure that it gets hit. So if I press play, it hits it. Okay. So we have a warning. Blah blah blah. Static aborting mobility. Ah, okay, great. That error warning is coming from the fact that when we add the spline mesh, we have this set to static. You can see it changes the details here. And if we check what we have in the map for this guy here, I believe this is set somehow to mobile or movable, I mean. So let's compile this and save and play. And what the? Well, hello. Well, hello there. Okay, so that's the original. Okay. I still have warnings. Why do I have warnings? Mesh, spline mesh component, but mobility is static. No, it's not. It's set to movable. I've seen this error before. I can't remember what I did. I'll figure it out in a moment. It's not really important right now. It's more important that I don't see anything at all. I'm just going to check what we have in the list of elements. We have a lot of members here. We have some points. And here's a 0, here's a 20, and here's 40, so on. Everything seems to be working all right. So why don't I get anything in my tree generator? Render tree. We know for a fact that it's going to call it. And we know we have members in here, and we know we have... Do we know we have points coming out here? What we can do is to do a quick print. And get the length here, and output that and compile. So if we switch in here, we can see it outputs some numbers here. So that's an indication that we are getting segments. So let me get rid of that again. Now that we have that in place. And we have the width. So it could maybe be a good point to print out the width here just to make sure that it's not 0 or anything weird. So it's definitely not 0, it's going between whatever. So that should be okay as well. And then we have the loop body, and we add a spline mesh. We set the start and end in local space. We set the forward axis, and we set the scale and that stuff. Let me just try and bypass all this scale stuff here and just set the static mesh. Oh, so it is something with the scale. What is up with the scale? Interesting. Do I have some dummy values here? I have 20. Local width segment with factor. Set this. Take this. That is actually pretty strange. Okay, I can't really figure that out. So anyway, I'm just gonna ignore it for now. And I'm gonna set a yaw to like 30 degrees. Ooh, whoa. I guess. And let's set a roll of 90 degrees just to see that we get a 90-degree angle every time. And that seems to be the case. And can also set it to this. And I kind of want to get the, let me just set this to 1, and that was the length and the segment width. I'm going to set this to 1, and then I'm going to call the set start scale again. Okay, and then it disappears. Great. Parent with scale. Set that. Oh, are you kidding me? I have 2 of these guys here. That was a tricky one, huh? Get rid of that one. Okay. Of course, that was the wrong one. God damn it. That was one of the better mistakes I've made. I think I should go to bed and continue this another day, really. Oh, forgot this one. Set it. And there we go. No? Oh yeah. I just need to 0.9. 0.8. Yes. Very nice. Very good. Okay. So let's set this to 0.7. To make it a little bit smaller. What happens if I set this to 10? Is it gonna go crazy? Okay, it's awfully slow, but I guess there's a reason for that. I'm not really sure why. So anyway, we have a little tree generated now, and all I need to add is the randomization. Let me just add that before I end this video, and then we can start to look into the collision thingy. Initial generate branch. Okay, so I want to add the randomization. Why do I want to add this? I want to add this in the beginning. Actually, every time I move forward. Yeah. Actually, one interesting point to note here. I don't know if you realize that, but since we have 10 segments per branch, we should expect to have 10 segments here, but we're actually not getting 10. We are probably only getting 1, 2, and then it's gonna skip, because once it comes out here, it's gonna say, should we create a branch? Yes, we should create a branch, and then it's gonna go make a branch. And the next time, that means 3, it's going to go down here, and then it's going to make a point or segment. But when it made that branch, it didn't make a segment for that one. So it's not going to generate 10, but it's going to generate every 2, it's going to miss 1. Just a small detail. So I just wanted to add this randomization, so let me do that real quick. We're gonna add random x as a 2D vector. I'm gonna put this in the branch section, make it public, and compile and save. And then I'm gonna duplicate it, and I'm gonna duplicate it and call this one random y and random c. And let's add the randomization before here. So we're gonna take our little turtle, add local rotation, split this open and connect this up. Yeah. And we're gonna get this and this, oops, wrong one, this and this, split, split and split, random, float in range, something like that. Connect that one up and that and that. And I'm missing space here, so let me just I'm gonna do something else. Ooh, all of it did move. How was it? Anyway, let's compile that and save and make a last test. So let's give this minus 20, 20, minus 20, 20, minus 20, 20. There we go. Now we have a randomized tree. Whee! It's kind of slow. I think it does generate, well, 200 segments. I have a feeling that this this recursive function stuff isn't the most optimal way of doing this. It's just a feeling I have. I'm not really sure if it's correct or not. And I should probably also do something with the logic for the thickening or making the branches thinner, because some of these kind of look like they were chopped off. I managed to do this in a kind of a hacky way in one of my early videos where I showed how I made it pointy at the end. And basically what I did was to say if I'm at the end, then I'm going to set the scale to 0. But I don't really like that. It should, yeah, do something else. I can't really decide. So anyway, that's it for this video. It's gone on for quite a long time. And finally we have a little tree here. It's kind of similar to the L system tree. The next video I'm going to take a look at how we can make this trace around something, and probably we're also gonna cover how we can make the leaves and to add a few other things as well. So stay tuned for more, and see you in the next. Bye bye.